Every once in a while, I'll get asked, where do math definitions come from? And when I get asked this, it's usually about definitions, but I'm going to include postulates here since the answer is the same for both of them. So, first, let's be clear about what these things are. A definition in math is the same as it is in English. It's a statement that tells us what a word or a phrase means. In this case, what we mean by the phrase parallel lines. Postulates, on the other hand, are things that we're going to assume are true without any kind of proof. For example, this is Euclid's first geometry postulate. It isn't defining a term so much as it's telling us something we're going to assume to be true about the relationship between points and segments. Okay, so where do these things come from? Well, the answer is two places, and these two statements are good illustrations of both of them. One source is the real world, and that's where most of Euclid's postulates come from, for example. They describe real world physical relationships that, with just a little experimentation, you can see are going to be true, sort of. Euclid's first postulate actually has a small problem, but for more about that, check out our video on what we mean by mathematical rigor. Now, the other place these things come from is a little more abstract. We choose them because they generate interesting results. And the parallel lines definition kind of falls into this category. There's no special reason why we should include this part about the lines being in a plane. If we took it out, the definition would still make sense, but the objects that fit it wouldn't be nearly as interesting. That is to say, there wouldn't be nearly as many interesting and useful properties that they have. So, how could this impact your teaching? Well, when you see a definition like the one for parallel lines, and it has multiple requirements like in a plane and don't cross, one thing I'll do is I'll take parts out of the definition and ask my students to think about how the things we get with the modified definition differ from the things that we get with the original one. This gets them thinking about the definition in a creative way, which is something students aren't encouraged to do enough with math, and it helps to clarify in their minds exactly what the definition is trying to tell them. So if you like this video, don't forget to click on the like button below, and you can click on the subscribe button if you'd like to see more content like this.